Okay, so we're going to find the domain of these functions. So the first function is a polynomial. So there are no numbers that cannot be entered into this equation and end up with a result. So the way that we can say the domain, which are the allowable x values, are all real numbers. That's one way we could say it. We could say that the domain is from negative infinity, x is the variable, to positive infinity. We could also show it with a curly bracket, negative infinity, comma, positive infinity. So those are the three ways that we could talk about the domain. Now, number 57, the only value of t where this is not a real number, is undefined, is when t equals 0. So what we could say is the domain is all real numbers except t equals 0, because that'll make the denominator go to 0 and you'll have 4 over 0, which is undefined. Another way you could do it is negative infinity, and the variable is t, and go to 0 but not equal 0. And then you could go on the other side of 0 to positive infinity. That would be one way. And the third way is we would have a curly bracket or a curved bracket, negative infinity 0, and then 0 comma positive infinity. Now number 59, when you have a square root, the key is that the argument of the square root has to be greater than or equal to 0. So we would say to have the correct domain, we'd say y minus 10 has to be greater than or equal to 0. So if you add 10 to both sides, you have that y has to be greater than or equal to 10. So that is the domain using the greater than, less than. You could also say 10, that y is greater than 10 and less than infinity. You could also have, in this case, because it can be equal to 10, we would have a square bracket. So we'd have 10 comma positive infinity with a curved bracket. That says it's never equal to infinity, but it can be equal to 10. Now when you have separate parts like this, you may say, well, I can look at each one and see where that goes to, where the denominator goes to 0. And I think that works out in this case, but it's usually good from a standpoint of evaluating things like the x-intercepts. You don't want it in this form. You want it into a single fraction. So what I'm going to do is I'm going to find a common denominator. And when you have just two fractions, you can sort of do a cross multiplication. So you take 1 times x plus 2, and then you subtract x times 3, and then you divide by the product of those two. So what we do is we multiply out everything in the numerator. So you get 1 times x is x, 1 times 2 is 2, and then you have x times negative x times 3, which is negative 3x. The denominator stays the same. Then you combine like terms, so you have negative 2x plus 2 divided by x times x plus 2. So as far as the domain is concerned, you could have answered the questions using that, but this would allow you to find the x-intercept by setting the numerator equal to 0 and finding the values of x where the numerator goes to 0, which in this case would be 1. They're not asking that in this problem. So in this case, you could say the domain is all real numbers except x equals 0 and x equals -2. And those are the two values of x where the denominator would go to 0. You could say -infinity, x is greater than -infinity, and you would go to the most negative term. Then you would go from -2 to 0, and then you would go from 0 to +infinity. So what this is doing is it's eliminating -2 and it's eliminating 0. From a bracket standpoint, pair, you'd have -infinity, comma, -2. You'd use curved brackets because it's not equal to -2. Then you go from -2 to 0, and then you would go from 0 to +infinity. Okay, the next one, there's two things to look at here. One is that if the denominator goes to 0. Now, if the denominator went to 0 where the other part of the function cannot be evaluated, then it would be treated differently. So I'm going to show you the answer to this one, and then I'll explain how if we switch this to 4 and that to 1, how it would be different. So, s cannot equal 4 because that would make the denominator go 0 to give you a undefined answer. Also, s minus 1 has to be greater than or equal to 0, or s has to be greater than or equal to 1. So that means we want to do this all real numbers except, because this covers a lot of numbers. So what we would do is we'd say s can be greater than or equal to 1 up to 4, and then you'd go from 4 to +infinity. So this tells you it has to be greater than or equal to 1, but not equal to 4. So we could also do it in this way. You'd have 1 comma 4 to a curved bracket. Then you have a curved bracket and infinity curved bracket. Okay, now let's say it was f of s equals the square root of 4, or pardon me, s minus 4 divided by s minus 1. Well, again, s cannot be equal to 1 because that would make that go to 0, but the upper term the argument of the square root has to be greater than or equal to 0. So s has to be greater than or equal to 4. And because this is not in this domain, we don't have to talk about it because it's not included in the domain required for this part to be satisfied. So for this problem, we would just say, s is greater than or equal to 4 and less than infinity. You could just show that. You could do a closed bracket. I mean, not closed bracket, square bracket, 4 comma infinity, right parenthesis. Okay. In this case, we have, now if this were the square root of x squared minus 9 were in the numerator, we would just need for this to be greater than or equal to 0. But because it's in the denominator, we can't let it be equal to 0, because then this would be, the denominator would be 0 and making it undefined. So we have to go one step further. We have to say x squared minus 9, it has to be greater than 0. Not greater than or equal to 0, but greater than 0. So what do we get? We get x squared is greater than 9. And the question is, what do we do now? because we've got, if you take the square root of this thing, what you would have is x has to be greater than 3, or x has to be less than -3, because I need for this thing to be positive. And if it's, say, +4, you're going to have 4 squared, which is 16, minus 9, which is 7, so that whole thing will be positive. But because when you square the negative number, this becomes positive, we want the squared to be greater than 9. And therefore, this has to be less than -3. So say you put -4 in there, and you'll get -4 squared, which is +16. So how do we write this in the appropriate way? So less than -3 means it's from -infinity to -3. And in the other direction, the other requirement would be that x is greater than 3 and less than +infinity, or in this format like that. So either one of those would be correct. Again, if we had something like the square root of x squared minus 9 over x minus 5, where we flip them, the only requirement is this is greater than or equal to 0. So we would have an additional, we'd have 0 included, whereas we can't have 0. This thing cannot be 0. So it would include plus or minus 3, basically. And we'd also have x equals 5 would be a case where the function could not be evaluated. It would be in undefined. So this particular function would have the following. So you'd have x is greater than -infinity, but less than or equal to -3. And then it would go from +3 to 5. And then finally, it would go from 5 to +infinity. So we can't evaluate between -3 and 3, but not including those two numbers, and we can't evaluate it at +5. So that would be the way we do that. So how would this look? -infinity with a curved bracket, -3 with a square bracket. Then we'd have 3, 5, but this would be squared, this would be curved, and then we'd have 5, infinity with two curly brackets. Okay, and the last problem, what we're doing is we're making radios, and the cost to produce a unit is $60 per unit. And for orders orders between 1 and 100, the price is $90. So the profits, the difference between those two, is going to be $30. But after we make 100 or sell 100, each subsequent radio costs 15 cents less. Now, the first 100 radios still cost $90 a piece, but as we go above that, then we reduce the price, and so the profit per unit is less when you're above 90. So the question is, from the table, estimate the maximum profit. So all you have to do is just kind of look, and you get to this number, which is larger than the previous one, larger than the subsequent one. So the answer would be $3,375. That would be the estimated maximum profit. And because this is symmetric, you got 3360 and 3360, it probably is the maximum profit. Next it says plot the table. So let us add a page, put in a piece of graph paper, and what we're going to do is I'm going to hide part of it, because we only have positive numbers, so it's better to just show the positive part. So this, the y-axis is the profit, and the x-axis is units. And let's start, this is 0, so you'd have, let's do, and we need about 200. So let's make 5 steps be 100 and this be 200. And then we'll go from, we could go from 0, but probably what we do is we'd start at a number closer to something like that. So what we'll do is we ignore these for right now. We'll just look at that. So the 0 here, the lowest number, I'm going to make 3,000. So this is 3,000. And we need to go almost 3,400. So if I go every 2 units is 100. So that would be 3,100. That would be 3,200. That would be 3,300. That would be 3,400. And then the highest will be 3,500, which is going to be greater than any of those. So now we're going to go through and just plot these. So 110, 1,000, 3,135, which should be about right there. 120 units would be 3,240, which is about right there, because this is 100, so this would be 50, so that would be about 40. At 130, which would be about here, we'd have 3,315. So this is 3,300. That's 3,350. So 3,315 would be there. 150, or 140, which would be here, would be 3,360. So that's 3,350. 3,360 is about there. 150 units. Should be here, and the x-axis would be 3,375. So this is 3,350, 3,375, be right in the middle. And these points are going to be symmetric, I think, 3,360, 3,315. So it would look something like that. So if we plotted this function, which it is a function because it passes the vertical line test, for each value of x is only one value of y. So that's the curve. So plot the table. Is it a function? Yes. If p is a function, write the function and the domain. So the domain is actually the values that we have in the table. And it has to at least be greater than 100, because at 100, if you think about this, let's go back here. So if you had 100 units and the cost was $60 per unit and the price is $90 per unit, the profit per unit for each of those 100 is $30. It's the difference between the two. And so the total profit is the profit per unit produced times the number of units, which would be $3,000. That would be this point right here. And then you could say, okay, well, how far would this equation be good? Well, one thing you could say is that I'm not going to say, if I get a profit less than 0, or really there's not much point in selling more units if I end up getting less profit. So you'd probably say I'm not going to produce any more than 100 and whatever the maximum value was. What did we say it was? 150 give you the maximum profit. So anyway, what we'll do is we'll say the domain. We'll say we're not going to, this equation that we're going to come up with has to be greater than or equal to 100. What was that? Okay, they used x for the, and as far as the maximum is concerned, we'll just go to 170, because that's what the table did. Cost per radio, once you get more than 100, is going to be reduced by 15 cents, and each one of those additional ones is going to reduce the price of every one of them, not just the next one is reduced by 15, but they're all reduced by 15 cents as you get over 100. So for example, as they give an example here, they say that the price per radio when you have 120 radios, what you do is you take 120 minus 100, which is 20 radios, and then the price per radio is going to be equal to the original $90 minus 20 times 15 cents. So that becomes 90 minus 3, which is $87 per radio. And then you multiply that. That will be the total cost. Well, you would take 120 times 87 to get the total cost, and then you would not the total cost, but the total price, the total revenue, and then you would subtract the cost. So let's see how that works. So the profit equals, we'll say, revenue, which is how much you make, minus cost. Now the cost per radio is the same. It's going to be $60, and the total cost is $60 times X. So that doesn't change when you make the larger amount. Now the revenue is going to be equal to 90 minus 0.15 times X. So that's the price per radio times the number of radios. And you subtract the revenue from the cost to give you the profit. And so you can try, and we know, well, let's see at X equals 100. That's just before this price break comes into account. The profit should be, there's $30 profit per radio. It's 90 minus 60. And so 30 times 100 is 3,000. So the first thing is that if I let X equal 100, then this thing should equal 3,000. And I've already seen a problem here. So what I have to do is I have to make a slight correction. So the amount that's reduced is the number minus 100. And then the whole thing, let me just move this over a little bit, times the number. So this is the cost. So trying our example here, you have 0.15 times 120 minus 100, which is 20, that's that number, times 0.15 from 90. And then you multiply that by 120 radios, and you're in good shape. So that seems to make sense, but let's just double check it. Well, we just did. So at X equals 100, this should be the profit based on this equation that's good for 100 or greater. So you'd have 90 minus 0.15 times 100 minus 100 times X, which is 100 minus 60 times X, which is 100. So this goes to 0. So what you're left with is 90 times 100 minus 60 times 100, which is 9,000 minus 6,000, which is 3,000. So that worked out pretty good. Let's check another point that we have a graph point on the graph. So we know at X equals 170 that the profit should be 33.15. So let's do that. So profit equals 90 minus 0.15 times 170 minus 100. That whole thing times 170 minus 60 times 170. So I'm just plugging x into this equation. So we get 90 minus this thing. So what we'll get is we'll get 170 minus 100, which is 70, times 0.15. So it's reduced by $10.50. And that's multiplied by 170, and then we subtract the cost. So we take 90 minus 10.5, which is 79.5, times 170. That's 13,000. First number is 13,515, and 60 times 170 is 10,200. And if you take the difference, you get 13,515 minus 1020, 10,200, and I get 33.15. So that double checks it. So that is the equation. And probably what we would do is we would just multiply everything out and combine like terms. So if you take 90 times x, you get 90x. Then we would have 0.15, negative 0.15 times x. So that'd be times x squared. So it's this times that. And then the last one would be negative 0.15 times negative 100 times x minus 60 times x. The last thing here. Okay, so we got 90x minus 0.15x squared, and 0.15 times 100 is 15, and the negatives cancel out, so you'd have plus 15x minus 60x. And if you combine all the terms involving x, you'll get 90 minus 60, which is 30, plus 15, which is 45. So you get 45x minus 0.15x squared. And so again, we could try those 2 points. If we stick 100 in there, we should get 3,000. So 45 times 100 minus 0.15 times 100 squared is 3,000. So that's good. And if we do 170, we'll have 45 times 170 minus 0.15 times 170 squared, and that should be 33.15. 45 times 170 minus 0.15 times 170 squared. And I get 33.15. So that's good. So that is definitely the right answer. So this was before simplification. That was after simplification, which is easier to look at.